In the previous lesson, we encountered a problem. The loading process takes a long time and blocks the main thread. That's why when we click the button, the timer stops displaying any values, no text is shown, and only after all the text has been loaded, the timer resumes its work and the button becomes active. The thing is that all the code you wrote is synchronous. It's executed sequentially line by line. And at the moment when we try to load the book, we simulate a long loading process. Here the thread stops for 3 seconds, and further code, as well as updating the user interface, doesn't happen. Then the book is loaded. We set the text in the text field. It doesn't have time to render before we start loading the author. And again the thread is stopped. How can we tackle this problem? We can move all long-running operations to a background thread. Let's do it. In the method loadBook, we create a new thread and immediately start it. We'll use the function thread and move all long operations there. And here we get an error. In the method loadBook, we create a new thread and the code continues executing. There is nothing after that, so the method loadBook finishes and we need to return an instance of the class book. But the book hasn't been loaded yet and there is nothing to return. So we can just write a return inside the thread. At this stage, after the 3 seconds delay, the method loadBook will have already finished its work, and there is no one to return this book to. From this we can see that in our case, synchronous or sequential code doesn't suit us. We would like the book to be loaded, and only after that the next actions would be executed. Displaying data in the user interface, and starting the author loading. In this case we can use the mechanism of callbacks, and this is done as follows. The method loadBook will no longer return an instance of the class book. It won't return anything. Instead, as a parameter, this method will take a function. Let's give this function the name callback. This function in turn will take a book as a parameter and will return nothing. In this case, after the loading is finished, when 3 seconds have passed, we don't return the class book. We call the passed-in function. We call callback and pass the loaded book to it as a parameter. Now when calling the function loadBook, we can pass a lambda expression as a parameter. This lambda expression will accept the book as a parameter, and inside it we will be able to use it. Let's see how it's done. Now this function returns nothing. We remove the creation of the book instance. And since this function takes only one parameter, lambda expression, parentheses can be omitted, and we immediately open curly braces. And here in this lambda expression, the book is passed as a parameter. And this parameter is the only one, so it's named it. But to make the code more readable, and to make it clear that it is a book, we can give this parameter a name ourselves. Let's name it book. The type can be omitted, and inside the curly braces, we will perform all these actions. We move the code here. Note that now our code is no longer executed sequentially. We start loading the book, and then the code continues executing. We can make sure of it. Right after starting the book loading, let's set the enabled value of the button to true. That is, if our code is still synchronous and runs sequentially, the following actions will happen. The button will become inactive, some text will be set, and then the book loading will start, and the book will be loaded, other text will be set, and then the author will be loaded, author info text will be set, and only then the button will become active. But if you run the program now, you'll see that it doesn't work that way. We click the load book button and see that it immediately becomes active. We can click it again. This happens because now our code has become asynchronous. We started the book loading, and the code continues executing, and the code inside the curly braces will run sometime in the future, after the book is loaded. This approach is called callbacks. At some moment in the future, this function is called. You're watching a video from our Kotlin programming course. I've left a link to the full version of the course as well as the biggest discount available in the video description and in the pinned comment. Enjoy watching. Now to make sure you understand the material, modify the function loadAuthor so that it also uses the callback mechanism. I'll give you a few seconds to pause this video and try it yourself. Good luck! Well, I hope you succeeded. Now this method returns nothing. We remove the return type author. And as the parameters, this function now takes not only the book, but also a callback. This callback is a function that takes the author as a parameter and doesn't return anything. Inside this function, we start a new thread, and inside it perform all these actions. Now instead of returning an instance of the class author, we call the provided function callback. In 3 seconds, this function will be called, and all the necessary rendering will occur. Now let's fix the call to the function load author. We are not saving the value to any variable. We are starting the loading process, and after that we pass a lambda expression. Let's also name the parameter author. That's not necessary. You can work with the variable as it. But this may cause some complications. Considering that one lambda expression is nested inside another, the parameter here would also be called it, as well as here. This might slightly complicate the understanding of this code. And after the author has been loaded, only then we enable the button. Let's move this code here. This was just for the example, to show you that the code is no longer synchronous. Let's run the program now to make sure it works. As the time is displayed, we click the Load Book button. We see that nothing is being blocked, the button becomes inactive, and all the text is successfully updated on the screen. Let's make one more small change, so that the timer also runs in the background thread. No callbacks are needed here, because this function returns nothing. So today we cover the mechanism for asynchronous work, which is called callbacks. Normally we write code that executes sequentially, line by line. But there are situations when we cannot immediately continue executing the program due to some long-running operations. In that case, the program might freeze for a while. This would be very bad for the user, and your app will get a poor rating. That's why, to avoid blocking the thread, long operations are moved to other threads. And if we need to get data from those operations, we use the callback mechanism. This means that the code is no longer synchronous. The call of this function, callback, is not called immediately, but at some point in the future. The loading finishes, and then the callback function is called. And then at some point in the future, the code inside the curly braces will be executed. This approach is widely used in practice, but it has its downsides. The main one is being known as callback hell. Notice that we call the function loadBook and pass a callback. Then, inside we start loading the author and pass another callback. In real programs, you can end up with a huge number of nested callbacks, which makes it harder to read the code and maintain the operation of the program. So this approach exists and is used in practice, but Kotlin language developers came up with a way to simplify working with callbacks and introduced coroutines. We will start learning them in the next lesson. And now we want to cover one more small thing. Some students have the following question. What if we don't use callbacks at all, and simply create a new thread where we call the function? Let me show an example. Let's say we have some long operation, from which we expect to get some data. Doesn't matter what, for example a string. Here we put the thread to sleep for 5 seconds, and then return some string. In our example, we created a new thread right here inside, and sent the loaded data through the callback. But the student asked, what if we don't use any callbacks? Leave the function as it is, and in place where we need the data, just create a new thread, and call the long operation function to get some data from it. And in fact, you can do that. The program will work fine, but this breaks the rules of clean code. Why? We already discussed that if your code is written well, then you don't have to look at its implementation to use it. You can just call all the necessary methods wherever you need them. But if you leave the method in such a form, then it won't be obvious at all that the method call needs to be moved to another thread. One of your colleagues might call this function you created, the app will freeze, and it won't be clear why this happened. So you should write the code in a way that it can be used anywhere without breaking the app. In case the functions with callbacks, they can be called anywhere. They definitely won't break the app. All necessary thread switching is implemented directly inside this function. You don't need to look inside its implementation to use it. But with this approach, you just have to hope that the one who calls the function runs it in a background thread. That's why you shouldn't do it that way. We delete this function. This information will also be useful when working with coroutines. Once you feel confident that you understand what the callbacks are, why we need them, and what problems they have, then move on. See you in the next lesson.